So let's look more closely at loosely timed. So what is loosely timed used for? Well, it's used for early software development, maybe some hardware verification, and to speed up some of the other use cases, right? So the idea is just enough detail to boot the operating system and run multi-core systems, and processes are allowed to run ahead of simulation time, okay? So imagine, if you will, you've got these parallel concurrent processes going on that a lot of you are familiar with in your hardware, and one of them just sits there and runs, and it pretends that even though the time is currently 10 nanoseconds, it makes these calls to things, and the time actually, it accumulates locally the time, and it goes, oh, I'm now 1,000, I'm a millisecond out in front of the current clock before it stops and allows the rest of the system to start. Because if you're familiar with the simulation, once you have, until you say wait, until you release things, you can run as long as you like in the simulator. Okay, so we let them run ahead. Transactions in loosely timed really just have two timing points, begin and end. You call the blocking transport, and you have control from the time just before you get to it, the start of it, if you will, and then you come to the end of the transport. And it's possible that during the call to blocking transport, time actually moved forward. You hope in some sense that it didn't. You're trying to you don't want a context switch to occur, but it can happen. It's allowed. It's legal. Okay? And sometimes it's easier to code this, and that's one of the things, the less things you put in your code, the faster the model's going to run effectively. I mean, that's one way to think of why is ESL faster than RTL, or why are these things? Because there's less detail, okay? And since there's less detail, it must be easier to code.